video is on Floyd's cycle detection algorithm. A brief overview: you use this to detect loops in linked lists. It has linear time complexity and constant space complexity. It's also known as the tortoise and hare algorithm, named after the fable of the same name. How it works: you use 2 pointers to walk through a given linked list at different speeds. The first pointer moves 1 node at a time, called the tortoise. The second pointer moves 2 nodes at a time, called the hare. The hare reaches the end of the list, then there's no loop detected. If the 2 pointers meet each other or are ever the same, that means there's a loop in the list. If there's a loop in the list, we then go find the first node in the loop. Here is the algorithm for this. As you can see, we input a linked list L and 2 pointers hare and tortoise. The first time you call this, these will be both equal to the first node in the list. We then go next.next on the hare and tortoise.next on the tortoise. And if hare equals null, we return null, meaning there's no loop. And if tortoise and the hare are equal, that means there's a loop. And we set hare equals to head. And then while hare and tortoise are not the same thing, we go through and have hare equals hare.next and tortoise equals tortoise.next and check if they're equal again. Whenever they are equal, they'll leave this and we'll return hare, which will be the first node in the loop. If tortoise and hare are not the same and hare does not equal null, then we go and call this function again and go to the next nodes. For a visual representation, we can see this. Using this, you can see they both start at the same node 0, or the head of the linked list. We'll go to node 1 for the tortoise and node 2 for the hare. 2 for the tortoise, 4 for the hare, 3 for the tortoise, 6 for the hare. And then finally they'll meet each other at node 4 for the hare and tortoise. But what if we want to know where the loop begins? How do we do that? Well, here's the math. We can break the diagram into 3 parts. As you can see, we have a line here that is the list leading up to the loop. Then we have a loop here, or circle here, and that is the loop itself. There are 3 parts to that. One is the distance from the start of the list to the start of the loop, x. The second is that the distance from the start of the loop to where the tortoise and hare meet, y. And 3, the distance in the entire loop, z. We can say that the distance traveled by the tortoise equals x plus y. And since the rabbit is moving 2 nodes at a time and the tortoise is moving 1 node at a time, we can say that the distance traveled by the hare is 2 times x plus y, because it's moving at twice the speed. But we can also say that the distance traveled by the hare equals the distance x plus some constant c times z, which is the length of the loop. And then we add y, meaning the hare could be looping here as much as it wants until the tortoise catches up and gets into the list. And then they'll meet up here. So if we set these 2 equations equally to each other and solve for x, we can see that x, the distance before or from the start of the loop to the beginning of the loop, is equal to some constant times the distance of the loop minus y. Meaning, if we leave 1 node here, have it run some constant amount of loops, moving 1 node at a time, and then subtract y from that, you'll be at the start of the list. And, depending on what that constant is, that will equal the distance from the start of the list to that node. Meaning, if we have our 2 nodes at where they met, leave the tortoise there, move the hare back to the beginning, we can then move them forward 1 step at a time until they meet again, and we can see they meet at node 3, which is the first node in our list.